Okay, so this is the proof of the series theorem. Any two subnormal series have the isomorphic refinement. Okay, now the next theorem is Jordan-Holder theorem. Okay, the statement of the Jordan-Holder theorem is Jordan-Holder theorem. Okay, look at the statement. Any two composition series of group G are isomorphic. Okay, any two composition series of group G are isomorphic to each other. Okay, in the previous theorem, we proved that the refinement of the subnormal series are isomorphic. Okay, in the definition of subnormal series was what is subnormal series? Each HI is normal in G. Sorry, each HI is normal in HI plus 1. Okay, H1 is normal in H2 is normal in H3 up to so on Hn which is equal to G. But here in the composition series, each Hi is normal in Hi plus 1. Okay, that is H1 is normal, maximal normal, not only normal. Okay, in the composition series, each Hi is maximal normal in Hi plus 1, and the abelian group Hi plus 1, the factor group Hi plus 1 upon Hi is what? Simple. Okay, so this is the difference between subnormal series and composition series. So here we have to prove that any two composition series of group G are isomorphic. Okay, now write down first given things all. Given that suppose Hi and Kj be the two composition series. Two composition series of given group G. Given group G such that this singleton E is equal to, suppose this is H now, which is normal in H1, which is normal in H2, which is normal in up to so on, which is normal in Hn, which is equal to G, give it as an equation number 1. And similarly for Kj, the singleton E is equal to K naught, which is normal in K1, which is normal in K2, which is normal in up to so on, which is normal in Km, which is equal to G. Give it as an equation number 2. Okay, now we have to prove that these two composition series are there. Okay, not only subnormal. Every subnormal is not composition. Okay, but every composition is subnormal. We seen in the last lecture. Okay, okay. Here, these two series are composition series, and we have to prove that these two series are isomorphic. Okay, that is the number of subgroups of Hi and Kj are same. Okay, now look at it. We know that what we know, if G divided by N, okay, G by N is simple. What is simple? If and only if this capital N is maximal, okay, in G. We proved in the last lecture. G by N is simple if and only if N is maximal normal in G. Okay, any doubt? हे प्रूव्ह केले मागचं थेरम आहे का लक्षात?
Yes, sir.
G by N is simple if and only if N is maximal normal in G. Okay, thus from the series N1 and 2, from the series 1 and 2, Okay, this hi plus 1 upon hi is what? For all I running from 0, 1, 2 up to so on n minus 1. Okay, if I is equal to n minus 1, so here hn upon n we get. Okay, so this is hi plus 1 upon hi is what? Simple. Why? Because this series is what? Composition series. By the definition of composition series, H1, H0 is normal in H1 and H1 upon H0 is what? Simple. H2 upon H1, simple. By the definition of composition series. Okay. Factor group is what? Simple. There does not exist any proper normal subgroup for this factor group. Okay, so here hi plus 1 upon hi for r running from 0 to n minus 1 is what? Simple. Okay. Now here we get by the definition of composition series, this factor group is simple. So that implies this implies and implied this hi not only normal, this is maximal normal. It's maximal normal in what? H
Yes, I plus one.
plus 1 by the definition of composition series, or we can say that by this theorem, if g by n is simple, if and only if n is maximal normal in g. So here hi is maximal normal in hi plus 1. Okay, what is the meaning of this one? Hi is maximal normal in hi plus 1. That is, in between hi and hi plus 1 there does not exist any normal subgroup. Is it correct?
Yes, sir.
Okay, this is the meaning of maximal normal subgroup. That is, in between H0 and H1, there does not exist any any normal subgroup. In between H1 and H2, there does not exist any normal subgroup, proper normal subgroup. Okay. So here you get Hi is maximal normal in Hi plus 1. Okay. And also, Kj is what? Composition series. That is Kj plus 1 upon Kj is simple. This implies and implied by the above theorem. Kj is what? Maximal in Kj plus 1. Okay. For all j running from 0, 1 up to so on m minus 1. Okay. Here the Kj is maximal in Kj plus 1. That means in between K1 and K2 there does not exist any maximum, any normal subgroup. In between K2 and K1 and K2 यांच्या दोघांच्या मध्ये कोणी येणार नाही नॉर्मल सबग्रुप इन बिटवीन ओके कंटेंट इन K1 contain K1. Okay, in between K2 and K3 there does not exist any normal subgroup containing K2. Okay, any doubt?
No, sir. No, sir.
Okay. So thus look at this one statement. Statement कडे नीट लक्ष द्या. Thus by definition of maximal introduction, by the definition of maximal normal subgroup, okay, the introduction of introduction of any other normal subgroup, any other normal subgroup, okay, in between hi and hi plus 1 is not possible. Is it correct? Okay. Similarly, introduction of introduction of which one? Kj and Kj plus 1 now. Introduction of any other normal subgroup. Any other normal subgroup between Kj and Kj plus 1 is not possible. Okay, hence this implies, is it correct? The statement is in between hi and hi plus 1, introduction of any other normal subgroup is not possible. Why? Because hi is maximal in hi plus 1 and kj is maximal in kj plus 1. Okay, up to here, any doubt?
No, sir.
Okay, so the refinement म्हणजे याचे अजून छोटे तुकडे होऊ नाही शकणार. Okay, so refinement of hi and kj are not possible. Okay, refinement of hi and kj are not possible. So this implies itself they are refinement. Okay, itself they are refinement. But we know that any two composition series, okay, any composition series with subnormal, but converse need not to, no? Is it correct? Any composition series with subnormal series. And by the above theorem, which one? C's theorem. Any two subnormal series are isomorphic to each other. And m is equal to m. Hence the proof. Any doubt?
No, sir.
Okay, आता पहा इथेच पहा प्रूफ करायची गरज पण नाही याच्यावरून समजतं. Here h1 is normal in h0 is normal in h1 is normal in h2 is normal in up to so on hn which is equal to g. हा काय तुमचा composition series. हा काय composition series for g ना. Okay, by the definition of composition series is what? This h0 is maximal in h1. This h1 is maximal in h2. h2 is maximal in h3. hn minus 1 is maximal in hn. Okay, what is the meaning of h1 maximal in h2? There does not exist any proper normal subgroups in between h1 and h2 which containing h1. जो h1 ला contain करणारा कोणताही proper normal subgroup मिळणार नाही in between h1 and h2. म्हणजे ह्याच्यामध्ये अजून त्याचा splitting होणार नाही याच्यात. Okay. Similarly for kj. Okay, there does not exist any proper normal subgroups in between K1 and K2. Why? Because K1 is maximal normal subgroup of K2. K2 is maximal normal subgroup of K3. That means introduction of any other normal subgroup is not possible in that series, in both the series. Okay, so itself they are refinement. म्हणजे ते स्वतःच refinement आहे. Okay, सगळ्यात longest chain आहे. Okay. So this composition series is what? Subnormal series. This again subnormal series. Okay, and by C's theorem, any two subnormal series have isomorphically refinement. Okay, हे refinement पण आहेत. Subnormal series पण आहेत. म्हणजे ते कसे असतील? Isomorphic to each other. Okay. Any doubt?
No, sir.
Okay. Now the next theorem is कोण बोलते आपलं नाव काय? नाव काय आपलं? Hello. If a group G has composition series which composition series. Okay, if a group G has composition series and if capital N is the proper normal subgroup, proper normal subgroup of G, then there exists composition series. Composition series containing N. Okay, what is the meaning of this statement? G has a composition series and N is what? Proper normal subgroup. म्हणजे हा तुमचा काय N? A proper normal subgroup of G. Okay, and G has a one composition series. So then there exists a composition series containing N. म्हणजे जो काही तो composition series येईल, suppose H0, which is equal to singleton, which is normal in H1, it's normal in H2. Suppose this one is the series, capital Hn, small hn is equal to G. Okay, suppose this series is composition series. So then there exists a composition series containing N. Okay, so either this N, either with this N is coincide with H1, N कोणाला तरी हा H2 ला तरी equal असेल. This N is equal to either H3, H4 up to so on Hn minus 1. Okay, why not Hn? Because N is the what? Proper normal subgroup. Okay, why this N could not coincide with this H0? Because H0 is the improper. This one is improper, no? But here N is what? Proper normal subgroup of G. म्हणजे त्या सिरीज मध्ये H1 to Hn minus 1 पर्यंत कुठेतरी हा N तिथे कोणाला तरी कोइन्साइड होईल. ओके, एनी डाउट?
No, sir.
Okay, answer. Good. Let HI be the composition series. HI be the composition series of capital G. Then the singleton E is equal to H0, which is normal in, not only normal, maximal normal, because this one is the composition series. This is normal, maximal normal in H2 up to so on. This is maximal normal in Hn minus 1 is normal in Hn, which is equal to G given in question number 1. And by the definition of composition series, this Hi plus 1 upon Hi is what? Hi plus 1 upon Hi is
Simple.
simple. Okay, this one is simple for all I running from 0, 1 up to so on n minus 1. Okay, n थोड़ा क्या होगा n plus 1, पण इथं आपल्याकडे n plus 1 नाही आहे. That's why I running from 0 to n minus 1. Given that capital N is normal in G, it's proper normal in G. Proper normal in G. Thus, this singleton E is normal in capital N, which is normal in G. Okay, any doubt? It's subnormal series. Subnormal series for capital G. Okay, now let this singleton E is equal to K0. Okay, this K1 is equal to N and this K2 is equal to G. Okay, so by this notation we get the singleton E, which is equal to K naught, is normal in K1, which is normal in G, okay, which is equal to K2. Any doubt? This is equation number 2.
No, sir.
Okay, any doubt? Yes. Now, also we have define here. Hmm. What is Kij? Kij is nothing but Ki into Ki plus 1 intersection Hj. Is it correct? By the definition in the proof of C's theorem. What is
Yes,
Ki?
sir.
Kij is equal to Ki into Ki plus 1 intersection Hj. Where I running from 0, 1 and j running from 0, 1 up to so on n. Okay. Now, j. Okay. This is Hj. Now, also we get. Also we have. We get this Kij is normal in Kij plus 1. Okay, now consider Ki 0. What is Ki 0? By this one, by this formula, Ki into Ki plus 1 intersection H naught. Okay, so this is Ki. What is H naught? Kj plus 1 or Ki plus 1 intersection H naught. It's H naught here. Singleton E, no? Singleton E intersection with Ki plus 1. Chi singleton E say, no? This is singleton E. So it is equal to what? Ki. Okay, so Ki0 is equal to what? Ki. And what is Kin? This is Ki from this formula. Ki into Ki plus 1 intersection Hn, which is equal to Ki into, this is Hn. What is Hn? Hn is equal to G. Put here Hn is equal to G. So Ki plus 1 intersection G is equal to Ki plus 1. Okay, लहान कोण याच्यात Ki plus 1, smaller one, which is equal to Ki plus 1. Okay, any doubt up to here? So here we get
No, sir.
Ki0 is equal to Ki and Ki is equal to Ki plus 1. Okay, so thus we get the singleton is equal to K0, which is equal to K0, 0. Okay, put here 0. K0 is equal to K0. Okay, which is normal. Which is normal in K0, 1. Okay, I then होना तुमचा J constant, which is normal in up to so on, which is normal in K0, n. Okay, J तुमचा then होणार I तुमचा 0, 0, 0, 0, 1, 0, 2, 0 up to n. Okay, which is equal to what? K0 n. काय K1, which is equal to K1. Okay, from this one. ओके, हे दोन कशासाठी काढले कळतंय का तुम्हाला? ओके, लेफ्ट ही फर्स्ट टर्म काढताना याचा यूज होतो, शेवटचे K0 n काढताना ह्याचा वापर होतो. ओके, प्रॅक्टिस केल्यानंतरच हे कळेल बघ का, असं पाहून नाही करणार ते. Normal in K0n is equal to K1. Okay, which is not which is equal to what is this is K10. What is K10? K10 is equal to K1. Okay, that is K10, which is normal in K11. ओके, इथे काय होईल, जे रन होईल पुन्हा K1 2 up to so on. This is K1n. Okay, which is equal to what is K1n? K2. What is K2? G is equal to G. Okay. Any doubt up to here? What is K1? K1 काय तुमचा? N. Okay. हा तुमचा इक्वल, ह्याला इक्वल आला. K1 is equal to K1 0, which is equal to N. Okay. Any doubt up to here?
No, sir.
Okay. Hence, Bayes' theorem. One is isomorphic to what? This series. Which one? This series is isomorphic to second one. Okay. So hence, this hi plus 1 upon hi is isomorphic to kj plus 1 ki it. And it j hi is equal to into I to kji. Okay, so it from 1 and 2, this kij plus 1 upon kij is isomorphic to hij plus 1 to hij. Okay, any doubt up to here? So that implies this हा तुमचा कसा आहे होता, सिंपल. Okay, from 1 this is simple group. That implies this ki, but this is isomorphic to this one now. So this kij plus 1 divided by kij is what? Simple. That means this implies हा तुमचा सिंपल ही झाला आणि हा मॅक्सिमल नॉर्मल ही झाला. So the series this kij is what? Composition series. Okay, composition series containing n, hence the group. Okay, so this one, this series is what? Composition series containing n. Okay, any doubt up to here?
No, sir.
कळते का? हे तुम्हाला प्रॅक्टिस केल्यानंतरच कळेल. ओके, असं पाहून नाही कळणार. तुम्ही जर नोट डाऊन करत असणार तरच कळेल. हे असं पाहून कळणार नाही, प्रॅक्टिस करावं लागेल यासाठी. Okay. Now the next question is, show that if this singleton E is equal to H naught, which is normal in H1, which is normal in H2, which is normal in up to so on, Hn is equal to G. Okay, it's subnormal series. Subnormal series of a group G, and order of this hi plus 1 upon hi, this group, complete group, okay, factor group, is equal to, suppose this is si plus 1, say, okay, assume केलं याला, त्याचा order असा si plus 1 असेल, say, for all I running from 0 1 up to so on n minus 1, then G is of finite order of S1 into S2 into up to so on Sn. Okay, what is given to us? If the singleton E is equal to H0, H1, H2, okay, this is the subnormal series. That means each HI is normal in G. Okay, and the order of Hi plus 1 upon Hi, the factor group, the order of this factor group is equal to Si plus 1. Assume by finite for all I running from 0 to n minus 1. Okay, H2 upon H1, H3 upon H1. Okay, order of H2 upon H1 ka ye put I is equal to 1, S2. Okay, H1 upon H0 ka ye, what is the order of this one? Order of this one, put I is equal to 1, I is equal to 0. So here we get S1. Is it correct?
Yes, sir.
Okay. Hmm. Then we have to prove that the G is of finite order. And that order of G किती असेल? S1 into S2 into up to so on Sn. Okay, wait. Proof. Given that. Write down first. Given things off. A singleton E, which is equal to H1, which is normal in H1, is normal in H2, is normal in up to so on Hn, which is equal to G, is what? Subnormal cells. Okay, this is subnormal cells. Also, the order of Hi plus 1 upon Hi is equal to, what is the order of factor group? कैसे find करते हैं? Order of Hi plus 1 divided by order of Hi. Is it correct?
Yes, sir.
Order of Hi plus 1 upon order of Hi is equal to order of Hi plus 1 upon order of Hi. Okay, so this implies order of Hi plus 1, order of Hi plus 1 divided by order of Hi. H order क्या है बाजू के लिए अपन? What is the order of Hi plus 1 upon Hi? Si plus 1. Okay, so this is Si plus 1 for all I running from 0, 1, 2 up to so on n minus 1. You will an equation number 1. Okay, any doubt up to here?
No, sir.
No, sir.
Put I is equal to 0. This implies order of H2, sorry, order of H1, order of H1 divided by order of H is equal to what? Yes, 1. Okay, so this implies order of H1 is equal to S1 into order of H0. What is the order of H0? What is the order of H0? What is H0? What is the order of H0?
Singleton E.
1 ना order विचारतोय मी किती एलिमेंट आहेत H0 मध्ये okay this implies
Okay, sir.
order of H1 correct yes 1 okay now put I is equal to 1 what we get this implies order of H2 upon order of H1 is equal to okay put I is equal to the put केले equation 1 okay so this is yes 2 so this implies order of H2 is equal to S2 into order of H1 this implies order of H2 is equal to S2 into what is order of H1 hmm? What is order of H1
S1.
येस
S1.
वन. ओके, तुमच्या नोट्समध्ये तिथे S1 इंटू S1 झाले, ते करेक्शन करा तिथे. तिथे S2च्या ठिकाणी S1 झाले नोट्समध्ये. ओके.
Okay, sir.
So in general, we can say that order of HR. H3 kind order of H3, S3 into S2 into S1. Okay. So what is order of HI we get? SI into SI minus 1 into up to so on S3 into S2 into S1. Is it correct?
Yes, sir.
Yes, sir.
Now put I is equal to N minus 1. This implies order of Hn divided by order of Hn minus 1. Is it correct?
Yes, sir.
Which is equal to, what is the value of this one? Yes. काय म्हटलं आपण ह्याला? Put I, I ची व्हॅल्यू काय पुट केले? N minus 1. So N minus 1 plus 1, yes N. Is it correct? So this implies order of Hn. What is Hn? What is Hn? पहा ना, G ना. So Hn is equal to G. It is order of Hn is equal to order of G. हा तिकडे गेल्यानंतर काय होईल? Sn into order of Hn minus 1. This implies order of G is equal to, okay, Sn. Okay, order of Hn minus 1 का येईल ह्या दोन टूलनुसार. Okay, is it correct?
Yes, sir.
Yes,
So
sir.
here Sn minus 1 into Sn minus 2 up to so on S3 into S2 into S1. That implies order of G is equal to Sn into Sn minus 1 up to so on S2 into S1. That is finite. Hence the proof. Any doubt?
No, sir.
काहीच अवघड नाही, सोपं आहे. ओके. हां बोला, काय अडचण? काय अडचण असेल तर विचारू शकता. ओके, अजून एक थेरम घ्यायचं. नेक्स्ट क्वेश्चन. एनी डाऊट अप टू हियर? काही डाऊट्स आहेत का?
No, sir.
ओके.
No, sir.
Question. Next question. Show that an abelian group has a composition series. Abelian group has a composition series if and only if it is finite. ओके, एखाद्या अबेलियन ग्रुपला कॉम्पोजिशन सिरीज कधी असू शकते? जेव्हा तो फायनाइट असेल तेव्हाच. जर तो फायनाइट नसेल तर त्याला कॉम्पोजिशन सिरीज नसेल. ओके, show that an abelian group has a composition series if and only if it is finite. Okay, good. Necessary. Only part, or we can say that only part. Assume here, let G be an abelian group. Okay, G हा abelian group हा आपण assume केला आहे. And what we have to prove that? We have to prove that G is finite. Okay, G is abelian group as a composition series, then we have to prove that G is finite. Okay, G be an abelian group. Okay, let this capital HI be a composition series. A composition series of G. Then we have to prove that G is finite group. Okay, we have to prove that G is finite group. Consider the singleton E is equal to H naught, which is normal in H1, which is normal in H2, up to so on, which is normal in Hn, which is equal to G, give it in equation number 1, is what? Its composition series. Composition series for capital G. Okay, if this one is composition series, that implies the factor group Hi plus 1 upon Hi is what? By the definition of composition series, हा factor group कसा असेल? बोला पटकन. Hi plus 1, simple. Okay, is simple for all I running from 0, 1 up to so on n minus 1. Okay, now if we know that if G is abelian, okay, then any subgroup of G is abelian. एखादा ग्रुप जर abelian असेल तर त्याचा प्रत्येक सबग्रुप कसा असतो? abelian असतो. Okay, we know that the result if group G is abelian, okay, that means it satisfies the commutative property. Then प्रत्येक एलिमेंट त्याचा commutative property satisfy करतो. ओके, म्हणजे त्याचे सबग्रुप्स मधले पण प्रत्येक एलिमेंट काय करतील? कम्युटेटिव्ह प्रॉपर्टी सॅटिस्फाय करतील. म्हणजे त्याचा सबग्रुप पण काय येईल? एनी सबग्रुप ऑफ जी इज अगेन abelian. Any subgroup of G is what? Abelian. Any doubt? If G is abelian, then any subgroup of G is abelian. So that implies क्या होता आपला? चीज काय होता? abelian. Okay, G is what? abelian. Every subgroup is what? abelian. Okay, factor group of abelian is again abelian. Okay, that means this factor group Hi plus 1 upon Hi is what? abelian. And by the definition of composition series, it is again simple. Okay, simple group for all I. Any doubt up to here?
No, sir.
No, sir.
Okay, so this implies Hi plus 1 upon Hi is cyclic and prime order. ऐसा लगा. If Hi plus 1 upon Hi is abelian and simple, then Hi plus 1 upon Hi is cyclic group and is of prime order. Okay, you know that. What is the Lagrange's theorem? Okay, order of a subgroups divides order of group. Is it correct?
Group.
Okay, एखाद्या ग्रुपची ऑर्डर जर 10 असेल आणि एखाद्या सबग्रुपची ऑर्डर किती असू शकते? 1, 2, 5 किंवा 10 असू शकते. ओके, एखाद्या ग्रुपची सपोज ऑर्डर ऑफ G is 10, so there exists a subgroup of order 1, subgroup of order 2, a subgroup of order 5 and a subgroup of order 10. This is the Lagrange's theorem. Okay, but
Yes, sir.
the Lagrange, but converse need not true. Okay, Lagrange's theorem converse need not true. एखाद्या ग्रुपची ऑर्डर 10 आहे आणि एखादा जो ग्रुप आहे त्याची ऑर्डर आहे 2. ओके, हा एच ह्याचा सबग्रुप असेलच असं आपण सांगू शकत नाही. प्रत्येक काय सांगते मी, ऑर्डर ऑफ सबग्रुप्स डिवाइड्स ऑर्डर ऑफ ए ग्रुप. ऑलवेज order of subgroups divides order of a group. But if suppose order of group 10, order of a group is 10, ओके, आपण असं सांगू शकत नाही की एक ऑर्डरचा ग्रुप असेलच, 2 ऑर्डरचा ग्रुप असेलच, किंवा 5 ऑर्डरचा ग्रुप असेल, किंवा 10 ऑर्डरचा ग्रुप असेलच असं सांगू शकत नाही. ओके, but for abelian group the converse of the Lagrange's theorem is true. Lagrange's theorem for abelian group, सर्च करा है काय, गूगल करा है. If order of a group H divides order of subgroup divides order of H, order of G, order of a subgroup always divides order of a group G, and the converse is what? Suppose order of G is, suppose for example order of group is 10, then there exists a subgroup of order 10, 5, 2, 1. म्हणजे 10 ऑर्डरचा पण सबग्रुपला एक्झिस्ट होतो तो इटसेल्फ, 5 ऑर्डरचा पण सबग्रुप एक्झिस्ट होतोय, 2 ऑर्डरचा पण सबग्रुप एक्झिस्ट होतोय, आणि 1 ऑर्डरचा पण त्याला सबग्रुप एक्झिस्ट होतोय फॉर अबेलियन ग्रुप. ओके, फॉर इन जनरल द कन्वर्स नीड नॉट ट्रू, असूही शकेल किंवा नसूही शकेल, बट इन प्लेस ऑफ, instead of G is abelian, suppose G is abelian, then there always exists a subgroup of order 10, 5, 2, 1. Okay, so this is the Lagrange's theorem for an abelian group. Now here, Hi plus 1 upon Hi is what? Abelian and simple. What is the meaning of simple? There does not exist any proper normal subgroup. हा काय म्हणतोय, ह्याचा जर सबग्रुप एक्झिस्ट झाला, ओके, हा काय म्हणतो, अबेलियन आहे म्हणजे याचा सबग्रुप एक्झिस्ट होतो. ओके, सबग्रुप एक्झिस्ट होणार कशावरून, Hi plus 1 upon Hi is abelian. Okay, and every subgroup of abelian group is what? Normal. Next statement क्या है, every subgroup of abelian group is what? Normal subgroup. Okay, हे सांगितलं मी स्टेटमेंट. If group G is abelian, then every subgroup is normal subgroup. म्हणजे हा तुमच्याकडे abelian group. Abelian group म्हणजे काय, by Lagrange's theorem नॉर्मल सबग्रुप एक्झिस्ट. ओके, नॉर्मल सबग्रुप एक्झिस्ट म्हणजे काय असेल, तो सिंपल होईल का, मग नाही होणार. ओके, इथे अबेलियनही आहे आणि सिंपलही आहे. सिंपल काय सांगतोय, सिंपल ग्रुप टेल्स अस does not exist normal subgroup. Abelian tells if there exists a subgroup then it will be normal subgroup. मग याच्यावरून काय आपण कन्क्लुजन काढू शकतो, the order of that group must be prime order. या ऑर्डरचे ग्रुप कसे असायला हवी, प्राईमच असायला. तर एखाद्या ग्रुपची ऑर्डर सपोज 11 आहे, या 11चे डिवायझर एक्झिस्ट होत आहेत का, एक तर 1 असेल किंवा 11 असेल. ओके, प्रॉपर एक्झिस्ट नॉर्मल सबग्रुप एक्झिस्टच होणार नाही. जर झाला तर तो कसा असेल, नॉर्मल होईल. ओके नाही, म्हणजे या दोन कंडिशनवरून अबेलियन अँड सिंपल कंडिशन टेल्स that order must be a prime order, and we know that if the order of a group is prime then it is cyclic. Okay, any doubt?
No, sir.
ओके, कन्सेप्ट आहेत त्या दोन स्टेटमेंट मध्ये, एवढे कन्सेप्ट आहेत त्यात. ओके, कॉन्व्हर्स ऑफ लॅग्रेंजेस थेरम पुन्हा एकदा सांगतो, नीट लक्षात ठेवा काय सांगतो. कसा आला ह्याच्यावर, if Hi plus 1 upon Hi is abelian and it is simple, abelian tells that every subgroup of abelian is normal subgroup. ओके, जर याचा सबग्रुप एक्झिस्ट झाला तर नॉर्मल असेल. सिंपल काय सांगतोय, देयर डज नॉट एक्झिस्ट एनी नॉर्मल सबग्रुप. म्हणजे सिंपल काय सांगतोय, एक्झिस्ट होत नाही. आणि हा काय म्हणतोय, जर एक्झिस्ट झाला तर तो कसा असेल, नॉर्मल असेल. याचाच अर्थ काय, याची ऑर्डर काय असायला हवी, प्राईम ऑर्डर असायला हवी. इज इट करेक्ट?
Yes, sir.
जर प्राईम असेल तरच त्याचे डिवायझर एक्झिस्ट होत नाहीये. तर डिवायझर्स एक्झिस्ट झाले बाय द लॅग्रेंजेस थेरम, अबेलियन ग्रुपसाठी त्याचा सबग्रुप एक्झिस्ट होईल. ओके, that's why this hi plus 1 upon hi is what must be a prime order, and we know that if the group of order prime order, then it is cyclic. Okay. Suppose this implies order of hi plus 1 upon hi is what, pi plus 1. Okay, say त्याला आपण अजून prime number म्हणतो pi plus 1. By previous theorem, what we get, order of G is equal to P1 into P2 into up to so on Pn. ओके, तिथे काय होता, SI प्लस 1 होता ना. ओके, इथे काय येईल, S1 च्या ठिकाणी P1 P2 up to so on Pn. ओके, hence order of G is finite. Any doubt? Now if part, okay, if G is finite, okay, if G is finite by existence of theorem, existence of composition series, existence of composition existence of composition, there exists a composition series for G. Hence the group. Any doubt? Okay, so if
No,
the
sir.
group is abelian with composition series, if and only if it is finite. Okay, any doubt up to here?